Let's take a look at this example. I'm going to first redraw this circuit in order to make it a little bit simpler. So I'm going to have my voltage source, and I have my resistor R1, and I have my resistor R2, and because these two resistors are in parallel, so the order doesn't matter in this case, so I'm going to put my RL on the side and R3 inside, and this is my point A and this is my point B. Okay, so I have my resistor R3 over here, and I have my resistor RL over here. So this is my point A and this is B. Because we're supposed to Thevenize it, we're supposed to simply remove RL. So in order to draw the circuit twice, I'm going to just remove my resistor RL at this moment. Okay, so now we're supposed to find the voltage between these 2 points. Please notice that we have open circuit, so current is not going to flow because it's going to recognize it like a very large resistance. So voltage across resistor R3 is going to be equal to the voltage between these 2 points. So I can say that my VTH, Thevenin, which is equal VAB, is going to be equal to VR3. Okay, so voltage between these 2 points is going to be equal to the voltage across resistor R3. Why? Because these 2 points are, we can say, connected directly across this resistor, so we're going to simply measure between these 2 points the voltage across resistor R3. So in order to find the voltage across resistor R3, I'm going to use voltage division law, which says VR3, which is equal in our case VTH, is equal voltage source times R3 over R1 plus R2 plus R3. Okay, this is equal. So VTH is equal voltage source 15 volts times R3, which is equal 3 kilo ohms, over, I have 2 kilo plus 3 kilo plus 1 kilo. Okay, let me do everything step by step. So this is equal 15 times 3 exponent 3 divided by open parenthesis, and I have 2 kilo, 3 kilo and 1 kilo. This is 6 kilo. Close parenthesis, this is equal 7.5 volts. Okay. Next, we're supposed to find the RTH, okay, Thevenin's resistance. In order to find the Thevenin's resistance, I'm supposed to short the voltage source in this circuit. Okay, so I have resistor R1 and I have shorted voltage source. So I have over here R2 and I have R3 and I have my points AB. Now please notice that these 2 resistors are in series, so I'm going to find R1, 2, which is simply R1 plus R2, and I have 2 kilo ohms plus 1 kilo ohm, this is equal 3 kilo ohms. And now I can redraw the circuit again. Okay, let me draw this over here. So I have R1, 2, and I have R3. Okay, So these are my points A and B. So as you can see, these two resistors are in parallel, so I can find my RTH. RTH is equal R1, 2 times R3 over R1, 2 plus R3. Okay, because they are in parallel. So R1, 2 we found is equal 3 kiloohms times R3, which is also equal 3 kiloohms, over 3 kiloohms plus 3 kiloohms. This is equal 1.5 kiloohm. Okay, so we found RTH. Next, we can draw the Thevenin's equivalent circuit. So I have my VTH and I have my RTH over here. Okay, and I have my points A and B. Now, in order to find the current IL, I'm supposed to replace my resistor RL over here. RL. And now please notice that we have series circuit. Okay, so if you want to find the current in the series circuit, you simply divide voltage, VTH in this case, by the total resistance of this circuit. So I can say that my current IL, VL is nothing else just VTH divided by the total resistance in the circuit. So I have RTH plus RL, where VTH we found is equal 7.5 volts. So I have 7.5 volts divided by RTH 1.5 kiloohms plus RL, which is equal 3 kiloohms. Okay, this is equal. So I can write that IL is equal 7.5 volts divided by 4.5 exponent 3. This is 1.66 milliamps. Okay, so this is the current which will flow through resistor RL. Next, I can find the voltage which will appear across resistor RL. You can use voltage division law or you can use Ohm's law. So in our case, this time we can use voltage division law. So VL is equal VTH times RL over RTH plus RL. Okay, so this is the voltage division law. So this is equal, let me write this down over here, VL is equal VTH 7.5 volts times RL, which is equal 3 kiloohms, over RTH plus RL, which is equal 4.5 kiloohms. This is equal 7.5 volts times 3 exponent 3 divided by 4.5 exponent 3. This is equal 5 volts. 5 volts. So my VL is equal 5 volts. If you want to find the power at the resistor RL, simply calculate PL is equal IL squared times RL. So IL squared, IL is equal 1.66 milliamps raised to the second power times RL, which is equal 3 kiloohms. Okay, this is equal PL is equal 1.66 exponent 3 negative square times 3 exponent 3. This is equal 8.26 milliwatts. 8.26 milliwatts. So this is my power at the resistor RL. Next, I'm supposed to find the value of the load resistance to obtain the maximum output power. So in order to obtain the maximum power, right, your RL must be equal to RTH. Okay, so my RTH is equal 1.5 kiloohms. So in order to get the maximum power, you're supposed to replace RL by 1.5 kiloohms. So we found everything, whatever the problem was asking us. So we can say that the problem is solved.